Hi, my name is Anand, and this is the screencast for homework 4 of DevOps. Coming to the first part of the homework, which is the Docker Compose. For this, essentially, for each of these subtasks, I've created individual Docker files. Let's go through each one of them. Let's start with the Redis directory. Here, I've created a Docker file. This Docker file essentially defines how the Redis container should be built. And for the base image, I'm using Ubuntu. On top of the base image, I'm doing an apt-get update and then installing the Redis server. Also, I'm exposing port 6379, which is the default port for Redis servers. And as the entry point, I've given the Redis server, which is executed once the Docker container starts. Coming to the next one, which is a container for proxy. Inside this proxy folder, you can see there's a Docker file which I've created. Other than that, the proxy is implemented as a Node.js script, which is in main.js. And let me just go through the Docker file. As you can see, the base image is the CentOS. On top of that, we're installing Node and npm. And then we're copying the current folder, which is proxy, into /source inside of the container. And then we're doing a cd into the source folder and doing npm install. This installs all the dependencies that are needed to run the proxy. And we're also exposing port 3000, which is the port on which the proxy would be listening to inside the container. And as the entry point, we're giving node and the name of the proxy file. This will get executed once the proxy container begins to run. The next thing is the container for the node app. As you can see here, this is similar to proxy. We have the main.js file, which is the main code for our web application. And let me just open the Docker file. As you can see, it's very similar. We have a base image of CentOS. We're installing Node npm. Other than copying the source file into /source and running npm install, the extra thing that we're doing here is essentially we're downloading the Docker client binary and untarring it inside the container. The reason we need this is to implement the /spawn endpoint. The spawn endpoint essentially lets us create new VMs when the load on our web application is increased or any such situation arises. This is needed because this is needed to essentially create containers. Issue a container create command from within a container. We'll come into the details of this once we start spinning up containers. And also to as you can, I've shown you the Docker files for all three of these. Now I'm going to show you the Docker compose.yaml file which I've created, which is essentially used to orchestrate the whole creation of images and running of these services. So for this, I'm defining a whole three services. The first one is web, which is for the web application, and the build source is given as the app folder, which I've shown you before. And we're also creating links between web containers and databases. Databases essentially are a Redis container. And also the important thing to note over here is we're also mounting a volume. The volume that we're mounting is essentially this particular file, which is the socket that the Docker client uses to talk to the host machine. The reason we're mounting this is to enable the container to use Docker commands as if it's executing Docker commands on the host machine and not inside a container. And for the proxy server, it's more or less similar, and we only need to link between the web and database. There's no need to expose volume. And also we on the proxy server, because this is the one facing the host, we also need to expose the port 8080, which is used as the port for our proxy. And database is pretty straightforward. It just builds the Redis. It just builds the Redis image. Now I'm going to run a Docker Compose. Docker Compose build to essentially build all the services that are defined in the Docker Compose YAML file. This builds a whole bunch of images, Docker images. Later, once the images are built, we're going to do a Docker Compose up, which will bring all these containers up, and hopefully our web app should start running. This usually takes like about a minute or so. As you can see, it's downloading all the dependencies, etc., that we have defined in the Docker files, and it is building these images that are required to set up all the three services that we have defined previously. Because this is the first time we're running this is taking a little bit longer, and subsequent runs will be much faster than this. And now we can do a Docker compose up, which will start running all the containers for us. In this case, the Redis server, the proxy, and the node up. As you can see, we started getting logs from the database, the Redis web application, and once we make a request to the proxy, we should see logs from the proxy as well. The proxy is exposed on port 8080, and when we make a request, it is saying that the request was served by 172.3.3000, which is our web server, that is web 1. As you can see, the proxy got a request and it redirected the request to 033,000, which happens to be the web 1 container, which is servicing the command. Now here I'm just going to show you Docker PS and show you all the containers that are running. As you already would have expected, we have the database container using the database image, a container using the web application image, and a container using the proxy image. Now, when you do a list servers, it currently shows that we only have one server that is running. And to create a new server, I'm just going to use the spawn command. Now I'm going to try the list servers again. As you can see, it's showing me two different servers now. So essentially, the app is using the socket that we've exposed as a volume, talk to the host and talk to the Docker host, and essentially created a new DevOps homework for web instance. I'll just do a Docker PS and show you that that's actually the case. As you can see, this has just been created about 27 seconds ago by using the spawn command. So therefore, we are able to create new containers from within the application itself by using the links, the volumes technique that I had previously discussed. And also, if we look at the home page, you can see that right now this was served by 0.3, and if you keep refreshing, you'll see that this time it was served by 0.5. This goes to show that the proxy server is doing its job. So you can see that we were able to set up a Redis container, we were able to set up a proxy and a node app using just the Docker Compose utility. And because we already implemented the creating new containers from within the app container, I that kind of covers creating new servers as well. But I've also done the modification to infrastructure.js to spawn a new container, and I'll just show you that as well. For instance, if I did node infrastructure.js, this is now going to start a new container for me. It is running in the background, and the new tab, I'll just do Docker PS and show you the output. As you can see, 5 seconds ago, which was when I ran the node infrastructure.js command, it has created a new web server which is using the same image. And yeah, let me just go to the home page and see if that list that shows up in the list as well. As you can see, we now have 3 servers. One when we started, one when we used the spawn, and one when we used the infrastructure.js. This completes all the components of Docker Compose, the first part of our homework.